Dubai has already built the world's tallest tower. And now, it wants the skyline to rise again. Burj Azizi is planned to reach 725 meters, higher than almost every structure ever built. From the street, it may appear as one impossibly thin line of glass disappearing into the sky, but beneath that simple silhouette are thousands of decisions that cannot be wrong. This is the hidden story of how an empty site could become a living vertical city. Before the tower can rise, the ground must first be cleared, measured, divided into controlled work zones, and mapped against a permanent survey grid. Temporary roads are formed, safety barriers are installed, and enormous piling rigs move into position. Deep shafts are drilled slowly through the soil while excavated material is removed and the bore remains stable. Long reinforcement cages are assembled in sections lifted by cranes and carefully lowered into the ground. Concrete then fills each shaft, creating a hidden structural column beneath the city. One pile changes very little, but together, hundreds of them create the underground network that will carry the weight of the entire megatall tower. Once piling is complete, excavation begins inside a carefully supported perimeter. Shoring systems resist the pressure of the surrounding earth while pumps control groundwater entering the site. Layer by layer, the excavation becomes a deep engineered box. At the bottom, pile heads are exposed, trimmed, inspected, and tied into the foundation. Thousands of steel bars are assembled into an incredibly dense raft, while drainage lines, grounding systems, monitoring sensors, and surface penetrations are embedded before the concrete arrives. The aft is poured in controlled sections over many continuous hours. Temperature sensors track the heat building inside the concrete, while curing systems reduce the risk of internal cracking. From this foundation, the first walls of the central core begin to rise. Waterproof membranes and drainage layers seal the basement against the surrounding ground. New slabs connect the core, perimeter columns, parking levels, plant rooms, service corridors, and the foundations of the podium above. Then the tower begins its vertical climb. A self-climbing formwork system surrounds the central core. Reinforcement is fixed, the forms are closed, and high-strength concrete is pumped upward. Around the core, perimeter columns and beams establish the shape of each floor. Metal decking is laid, reinforcement is tied, and concrete completes another structural cycle. Tower cranes deliver steel, formwork, machinery, and prefabricated components to levels that grow higher every week. As one floor cures, the system climbs and the process begins again. At selected levels, enormous outrigger structures connect the central core to the perimeter columns. Hidden inside the building, these rigid zones help the tower resist wind and control movement at extreme height. As the structure climbs, its profile begins to narrow. Far below the active construction level, completed floors receive brackets for the first curtain wall panels. Large glass units arrive in sequence, are inspected on the ground, and then lifted into position. Installation teams align each panel against survey points, anchors, seals, and neighboring units. The facade rises behind the concrete structure, gradually enclosing hundreds of floors from wind, dust, heat, and rain. Near the summit, structural steel forms the tower's narrow architectural crown. Lighting equipment, facade supports, access systems, monitoring hardware, and maintenance infrastructure are integrated inside it. When the crown approaches completion, the tower cranes begin the difficult process of dismantling themselves. Final facade sections are sealed, pressure tested, cleaned, and inspected. At the base, the podium entrance and surrounding public spaces move toward their finished form. Protective films are removed, temporary access equipment retreats, and the completed exterior is slowly revealed. From street level, the scale becomes clear, a 725-meter wall rising into atmospheric haze. Inside the podium, the grand lobby begins as a vast concrete shell. Mechanical services, wall backing, ceiling systems, stone flooring, escalators, and elevator portals develop together. Once permanent construction is complete, specialists test lighting, doors, ventilation, environmental controls, and fire safety systems. Furniture, planting, and assistance points are then carried into position by workers, turning the empty structure into a functioning arrival space. Beyond the lobby, high-speed elevator shafts extend through an extraordinary vertical distance. Guide rails, landing frames, cables, sensors, safety systems, and elevator car assemblies are installed with extremely tight tolerances. Every cabin is balanced, aligned, loaded, and tested before a passenger is allowed to enter. At the upper transfer levels, sky lobbies connect these elevator systems into the building's essential vertical transportation network. Higher still, another unfinished floor becomes a panoramic restaurant and observation lounge. Exterior glazing, kitchen services, ventilation, ceiling, stonework, and a curved hospitality bar are installed gradually. Before furniture arrives, every surface, appliance connection, lighting circuit, and environmental system undergoes final commissioning. Tables, chairs, planters, and restrained interior details are then carried into place, transforming the empty level into a destination overlooking Dubai. On the residential floors, luxury suites begin as quiet concrete spaces behind the glass facade. Partitions define bedrooms and private corridors. Joinery, stone, timber, lighting, glazing details, and concealed services shape each interior. Completed rooms remain empty while specialists inspect finishes, air quality, controls, doors, and windows. Only after these checks are complete are beds, sofas, dining furniture, artwork, rugs, and planting physically delivered and installed. Elsewhere in the tower, the high-altitude infinity pool begins as a reinforced concrete basin surrounded by unfinished services. Waterproofing, drainage, circulation pipes, underwater lighting, stone finishes, and dehumidification equipment are installed in carefully controlled layers. The pool fills slowly while technicians balance temperature, circulation, water quality, and the overflow edge. Loungers, planters, towels, and a small number of guests eventually complete a wellness space suspended high above the city. Nearby, the sky ballroom begins as another vast structural shell. Acoustic panels, rigging points, event lighting tracks, stone flooring, movable partitions, and stage systems are installed together. Engineers test sound, ventilation, lighting, power, and emergency systems before the room can host a single event. Banquet tables, chairs, linens, glassware, and low floral arrangements are then positioned by hand, preparing the space for its first gathering. Inside the crown, the observation deck begins with exposed steel, unfinished glazing, and a protected opening in the floor. Thick laminated glass panels are lowered carefully into an engineered skywalk frame. Every panel is aligned against structural supports, seals, sensors, and safety barriers. Test weights verify load capacity while technicians inspect the laminated edges, balustrades, and monitoring systems. When the deck finally opens, visitors step across the transparent floor with Dubai hundreds of meters below them. But a building this tall depends just as much on the spaces that most people will never see. Mechanical floors distributed through the tower contain pumps, heat exchangers, pressure vessels, electrical switchgear, fire safety equipment, and vast networks of pipes. Heavy machinery is lifted onto prepared foundations and aligned over vibration isolators. Engineers flush pipes, test pressure, verify electrical systems, and measure vibration before operation begins. Once commissioned, these machines quietly move water, cooling, power, and fire protection through the tower every hour of the day. At the crown, another complex system is assembled to maintain the building's immense exterior. Curved rails, a rotating machine base, telescopic boom, wire ropes, motors, counterweights, and a suspended cradle are installed in sequence. Calibrated weights test brakes, cables, sensors, and emergency recovery systems. Once approved, the completed maintenance unit lowers trained technicians outside the facade, where glass panels, joints, seals, and lighting components can be inspected and cleaned at extreme height. At ground level, the final construction effort shifts toward the public arrival plaza. Stone paving, drainage channels, trees, irrigation, entrance glazing, lighting, and access systems are completed in controlled sections. The equipment gradually leaves, temporary barriers are carried away, and the surfaces are cleaned. As evening falls, restrained architectural lighting reveals the form of the tower without turning the facade into a digital screen. Below the podium, a separate mobility hub manages vehicles, passengers, and elevator transfers. Ventilation, smoke extraction, barriers, drainage, lighting, sensors, pedestrian routes, and durable lane surfaces are installed around the underground arrival area. Test vehicles verify gates, detectors, elevator access, and the safe separation between traffic and people. Once operational, the hub moves arrivals quietly beneath the tower's public spaces. Deeper inside, a central loading dock controls almost everything entering the building behind the scenes. Dock levelers, freight elevators, insulated doors, fire shutters, waste systems, ventilation, drainage, and screening points are installed and aligned. Every platform, door, sensor, restraint, and service interface is tested before deliveries begin. Then pallets, carts, food supplies, maintenance materials, laundry, and service staff begin moving through the vertical logistics network. The tower's command center starts as a protected room filled with open cable routes and unfinished equipment frames. Consoles, networks, backup power, emergency communications, fire alarm controls, security systems, and monitoring displays are installed in redundant layers. Engineers test every connection before the building's systems are allowed to operate together. From this room, trained staff monitor elevators, climate, energy use, security, fire safety, water pressure, and mechanical systems around the clock. At intervals higher in the building, refuge floors provide protected spaces during a high-rise emergency. Fire-rated walls, pressurized staircases, backup lighting, communications, medical support points, and accessible refuge areas are installed carefully. Pressure levels, heavy doors, emergency circuits, alarms, and ventilation systems are tested as one coordinated life safety network. During calm readiness drills, occupants learn how these protected floors would support an evacuation without panic. Before the tower can officially open, every finish, sensor, elevator, door, lighting circuit, and emergency system faces final acceptance. Protective materials are removed, furniture is aligned, equipment is cleaned, and the last defects are corrected. Engineers complete their inspections, temporary barriers leave the building, and the completed lobby stands silent for a final moment. Then the entrance doors open. Staff take their positions. Residents, office users, hotel guests, and visitors begin moving through the lobby. Elevators carry people upward. Escalators connect the podium levels. Restaurants prepare for service. Mechanical systems operate quietly behind the walls. The loading dock begins receiving supplies, the command center watches over the tower, and the illuminated crown becomes part of Dubai's night skyline. What began as survey lines on empty ground has become a complete vertical city. Supported by foundations buried deep below the streets, stabilized by a powerful structural core, enclosed by thousands of glass panels, and kept alive by systems most visitors will never notice. Burj Azizi is not simply a tall building. It is a coordinated machine, a workplace, a residence, a hotel, an observation point, and a new test of how far modern construction can rise. And when the final crane disappears, the real life of the tower is only beginning.
Purpose, educational purpose, and informational purpose. Using advanced AI tool and human creativity, all concept scripting and storytelling are independently developed to ensure originality. Visuals and animation are enhanced using AI technologies such as View 3, Meta AI, and Grok AI, while final editing and post production are completed using CapCut and other professional editing tools. No external creator content has been copied or used any resemblance to real world environment, factories, or processes is purely coincidental. All scenes shown in this video are digitally created and do not represent real footage. This content is produced with transparency and follows YouTube monetization guidance. Thank you and subscribe for more real videos. Manufacturing Factory.